What's going on, everyone? My name is Johnny Bannon, and I will be your CCNA instructor for this CCNA video series. And in this lesson, we're going to go over some file transfer protocols, TFTP and FTP. So let's all get excited, right, for some file transfers. So when I first saw this on the CCNA exam objectives, I was honestly surprised. I was like, TFTP, FTP, that's just something, as network administrators, we just kind of learn on the job and we just kind of know, I kind of forget even learning about it. It just happened quickly, as I started working in the IT field. And then I thought, there you go, makes sense. This is something people should know coming into the field, how TFTP works, the inner workings of it, and FTP. Because I have been in that situation troubleshooting my TFTP connections before, having to look up port numbers, having to understand that the source port and destination port actually change once you make that initial connection. And just little other nuances that now the CCNA is saying learn before you get to the job. So it's pretty cool. So that being said, let's go ahead and jump right into it. So first we're gonna go over our agenda. So we're just gonna do a quick overview of both the protocols, FTP and TFTP, because they accomplish a lot of the same things, with FTP being more feature rich. We're gonna go over the why, of course. Why do we need transfer files? Why do we need transfer file protocols? Pretty easy to understand from even like a user perspective why we need to transfer files between systems. But for networking specifically, what's the importance of it and what's a common use case of when we would use it. So that's important to understand as well. And then go over the operations of TTP and FTP, how they actually work, underlying how we're getting those blocks of data across that TTP and FTP connection. How's it actually working? Then we'll do some TFTP versus FTP. And then not on here, but we will go over it, some configuration as well. And then we'll have separate labs for TFTP and FTP. All right, so with that being said, let's go ahead and get started. Get my face out of here so we can do some real learning. So, quick overview. So the file transfer protocol and the trivial file transfer protocol, they're both going to be industry standard protocols that are used to do one simple task, and that's really to transfer files across the network. And it's really that easy to understand. Both FTP and TFTP can be used to back up iOS running configs, or to back up operating systems, the actual iOS, or to upgrade iOS on Cisco devices. So this is kind of like that test answer right there, right? Or what's important about it as far as it relates to network administrators. We can use these commands on the CLI or from actual TFTP, FTP servers out there in our network to actually do backups of our system, backups of our running configs, or to upgrade operating systems, to upgrade a file system in our flash. So that's the most common use case for these guys, these protocols, as far as networking goes. In our lab, we're going to do exactly that. In our lab, we're just going to send our iOS off to our FTP and TFTP servers and then pull it back. So a send and receive, essentially. And then both FTP and TFTP are going to use a client-server architecture. And as far as like the iOS goes, typically we're going to be the client, either sending off our iOS to the server or retrieving files from that server. So it is, but again, it is just a typical file or client server architecture. And then why we need it. So we kind of just went over that, but as far as networking goes, we need FTP and TFTP as a way to transfer our iOSs, backup running configs, or a way to upgrade multiple routers iOSs, all from one TFTP or FTP server. So you see here this a network administrator, he just set up maybe this core router in a data center for a new customer, and he's consoled in. And before he gets out of here, he wants to make sure he backs up the running config in this operating system, just in case when he drives 100 miles home and it crashes, he has a backup, doesn't do everything from scratch. So he makes a console connection in here, and on that CLI, he's going to say TFTP my iOS to this IP address, a TFTP server sitting out there either on his LAN or on the WAN. And that's a typical use case of what we're going to see network administrators utilizing these protocols. So now let's go over TFTP operation. So some basics we understand. is that TFTP is going to use UDP port 69. And since it's using UDP as the transmission control protocol, as far as the layer 4 protocol goes on this packet transfer or these file transfers, there's not going to be any reliability. We don't have to create a TCP three-way handshake and create that data channel via TCP. So the trivial file transfer protocol is not going to have it built into its transmission control protocol reliability. However, TFTP, the application, because remember, TFTP is an actual application, it's an actual resource that we can use, a protocol we can use. There is going to be acknowledgements built into the actual TFTP protocol application. And that is going to provide us with some sort of reliability where we're actually doing checks on our file transfers. And within TFTP, we can request for retransmission if we're missing something to that file, because we can't rely on our transmission control protocol to do it for us. So TFTP, if it comes on a test question, not saying, I haven't taken CCNA in years, but I could see this. If they ask which one's reliable, it's going to be FTP because it uses TCP. But we know, right, because we just learned it, we're expert network administrators, that TFTP is not just going to drop packets and send you half an iOS. Within the application, there is going to be some verification that goes on. And then TFTP also, just some more information, doesn't support authentication or encryption. So TFTP across the WAN is kind of dangerous, especially if you're not encrypting your packets via like IPsec or TLS SSL, VPN. That TFTP data transfer is going to be completely plain text. All right, so now kind of diving in a little bit more to the operation. So TFTP is going to send read or write messages or PDUs between the client and server. And then once that TFTP server acknowledges the write request, and that's kind of like our checks there, it's actually going to send an acknowledgement back within TFTP, not part of our IP header or our transport header. Then after that, it's going to send back our blocks of data. So kind of to break it down a little bit more, right? So let's say we want to send a write request from our client to our server, meaning we want to actually write something onto the server. We want to transfer a file and put it in a directory on this server. So we're going to send a write request, and our source port is going to be a completely made up ephemeral port from the client. So this is like our layer 4 header here, right? Our source port is going to be an ephemeral port that we just made up. Our destination port is going to be the TFTP port 69. This TFTP server is going to receive that write request and say, okay, I acknowledge that. You can make a write request, or you can write something onto my server. And then in the packet back, the source port, a lot of people think will be the 69 port, but it's not. It's actually an ephemeral port that the TFTP server made up. And we call this TID. So essentially now, when these client and servers are sending data packets back and forth, data blocks and acknowledgements, they're using these ephemeral ports that were randomly selected by the TFTP client and server. So kind of just a little extra knowledge for you, right? That the TFTP port 69 is only used on that initial request sent from client to server. And then the ephemeral ports that were made up are going to be used as a destination and source port. So you can see here that TFTP does have acknowledgements that are sent. That's an actual TFTP message type, an acknowledgement message. And then we're sending blocks of data. So they started with data block 0, sending that acknowledgement. And then the next step for our client, when we're actually transferring that file, because we did that write request, we're going to say, okay, here's block 1 with data bytes 1 through 15. And once this received all 1 through 15, it's going to send an acknowledgement back. If it doesn't receive all those data bytes, it's going to have a timer set up that's part of the TFTP protocol that says, hey, we need a retransmission of that lost data. We can tell there are segments missing in that TFTP data message, in that data block. So again, it has nothing to do with our layer 4 here. It's not TCP. The actual TFTP application is doing those checks. Then you can see here, we send a final acknowledgement, and then we receive that acknowledgement, and we're done with the transfer. And that's TFTP operation, guys, in a nutshell. So if you go over the TFTP message types, we have a read request, which is essentially us pulling a file, right? And then we have write request, which is us executing something on a file. And don't get too confused. Read, write, privileges, permissions are the same in really any computer system you're talking about. Then we have a TFTP data message, which is going to be that TFTP data, essentially, what we're actually transferring. And we're going to do a Wireshark capture of this and see. And then we have the acknowledgements, which is used by the server or the peer to acknowledge each block of data. And then an error, this is going to be used when one of the peers or that server client recognizes there's an error in that TFTP file transfer or data transfer. All right, so now let's go over some FTP operation. So a big difference between TFTP and FTP is going to be the layer 4 protocol and the port numbers that are used. So FTP is going to use TCP. So by default, we are going to have transmission control and reliability. So again, like test question scenario, FTP is the reliable file transfer protocol out of the two. We uses 2 port numbers. Port 21 is going to be used for what we call a control channel. This is where the FTP commands are going to be sent. And then for port channel or port number 20, this is going to be the data channel, which is actually going to do that file transfers. Kind of like in TFTP, those data blocks, that's going to be what this data channel is. This control channel, you may be asking, well, what's that for then? Well, FTP is a lot more feature rich than TFTP. With TFTP, you're kind of just either sending or requesting a file. That's it. That's all you're doing. You can't make any changes on the server's directory. You can't delete a folder. You can't create a new file name, or you can't change names on files. Well, technically you can, but I guess what I'm saying is you can't go to the server and change the name. You can change the name when you download it to the client yourself. FTP is going to give you a lot more features and controls to actually be able to navigate through the file directories of that server, of that client. So for example here, we have something called FileZilla. This is going to be like an FTP, essentially, yeah, I guess like a client. It allows you to pretty much FTP into any servers or any other FTP-enabled devices. And as you can see here, it actually lets you go through the directory of that system. And you may be saying, well, dang, that's pretty crazy. Who would just allow this? Well, FTP does use authentication. So to use FTP, you actually have to authenticate to the device you're connecting to with a username and password that has access to that device that you're connecting to. So with FTP, we have this nice GUI here, and FileZilla is one of many GUIs, where we can actually drag and drop files here. We can create new directories here. We can do a lot with FTP. And then by default, FTP is not encrypted. You know, these transfer protocols were made back in the 70s, really old, before we even thought about security on our networks. But enhancements that we have is we can add SSL or TLS to FTP to create FTPS. And then we also have something called SFTP, which actually is not the same FTP protocol we're talking about here. It stands for Secure File Transfer Protocol, but that S stands for SSH, and you're using an SSH channel, which again, RSA keys and all that, to do file transfers. But it's actually not the file transfer protocol. It's a little confusing there, but we're not going to dive too deep into that because it's not on our objectives. So now let's go over FTP operations a little bit deeper. So FTP is going to have 2 different modes, guys. It's going to have an active mode, and it's also going to have a passive mode, which we'll go over in the next slide. So the FTP active mode was the original mode we had, and it allowed clients to initiate FTP connections over any WAN, right? With the introduction of stateless or stateful firewalls, a client trying to get into your network or your domain through a firewall to initiate FTP connections on a server is typically going to be blocked. So the solution that was passive, which kind of just manipulates the port numbers, and we'll get into it, to kind of bypass those firewall limitations, originating from either inside or outside your network. Active mode was the first mode because really it's just kind of the easiest thing. It's just, hey, we're sending we're doing that file transfer. Send me a port to use, and we're gonna get into that. And we didn't have to really worry about security. So first, let's go over our active mode here. So in active mode, the FTP client will connect to the FTP server on the control channel, and it's going to be initiating the connection. You're going to see other videos out there tell you that the server initiates. That's not true. In active or passive mode, the client does initiate. If you actually look in the RFC of FTP, they're going to tell you this. So in active mode, what's going to happen is on that control channel, so again, using port 21, that should be a 21 right there. Let me just go ahead and change that now. Gotta love that I present straight off of Canva. Makes it easy to make these on-the-spot corrections. So let's get back to it. So the client is initially going to connect to the FTP server, and it's going to send what we call a port command. This port command is part of that FTP protocol, and it's going to tell the server which random port it's going to need to use to connect back to the FTP client on the data channel. So let's go over this. So essentially what we have here is this client wants to make an FTP connection to this server. So the first thing it's going to do is create that control channel. The destination port is going to be the regular FTP port of 21 for the control channel. This source port is going to be a completely made up random port, and this is going to only relate for the control channel. And the very first message it's going to send to that server, the first FTP command it's going to send is this port command. And in this port command, which is this right here, it's going to tell that server, hey, when we make our data channel, make your destination 4775. That's the port that I'm going to be accepting and listening for on the data channel from you. So this client pretty much opens up port 775 and is now listening to an FTP connection coming in on him. So the server is going to send back an acknowledgement and say, awesome, now I know how to connect to you, so now we can actually do some file transfers instead of just relying on our control channel for communication. So then the server is going to initiate the data channel back to the client, with the source port being its FTP data channel port, and then the destination port, another little mistake here. I'll go ahead and fix that. The destination port is going to be the port 4775, which the server learned about from the port command on that control channel, the initial channel and client connection that it made. So that's going to be active mode. The client initiating the connection over the control channel and telling that FTP server which port to use when creating the data channel connection back to the client. And then once that's done, we can go ahead and start doing some file transfers. Now let's go over passive mode. So in passive mode, you're going to hear a lot that the client actually doesn't start the connection. And that's going to be false. The client doesn't start the data channel connection, but it sure does initiate the connection on the control channel. So the major difference is, instead of the client telling the server what destination port to use, it's going to send a PASV command, another FTP command, and we remember our FTP commands get sent over the control channel, which will request a port number to use as a destination port for the data channel. So this is going to be like, hey, tell me what port I need to use. Tell me what port I need to use so we can create a connection together on the data channel. So the server will respond with a random port number the client can use to initiate a data connection. And then once that pass message is responded to by the server, and you see here, hey, use this port number. So this is how that passive mode kind of gets bypassed by the firewalls, is if it's stateful, right? And let's say we're going into the network or we're coming out of our network, this is where the firewall sits, over to a server. If we're initiating that data channel, the firewall is going to let us make that connection to our FTP server over here, because if it's stateful, it's going to be like, okay, you initiate the connection, I'll let it back in as well. So it's kind of how passive mode can be used, especially on our public facing FTP servers. So now that we had our path message or command responded to, we know that when we make that data connection, we're not going to use the typical port 20. We're going to use the destination port 4889. And then our source port, again, is just going to be an ephemeral port that we make up. And that's how passive mode kind of gets past those firewalls as well, because the destination port is not going to be that typical 20 port. It's going to be a completely different destination port that we create that data channel on. So pretty cool. So I hope that kind of breaks down the two different modes. I know that can be a little confusing, but I hope that helped. And then let's just cap off this general lesson with some TFTP versus FTP before we get into CLI. So the file transfer protocol uses TCP ports 20 and 21. And again, remember, this kind of actually depends on whether or not you're active or passive mode for that data channel port. And then FTP can use a GUI to send FTP commands to either transfer, update, or delete directories on a client or server. And then you also have enhanced security with TLS and SSL on FTP. TFTP is going to be unreliable. It's going to use UD port 69. Clients do not have any of those additional features. You're just copying files to and from client to server. That's it. Then TFTP does not offer any enhanced security, no authentication, and no encryption. None. All right, now let's get into a little CLI commands. So the TFTP command on iOS is so simple, guys. Let's just go over it. So you can see here, what I'm doing here is I want to send the iOS that is stored on my flash. Remember, like the hard drive of my iOS. So I want to get the file name. So I'm going to do this command at privilege mode. dir, which is essentially is like directory flash. And this is going to give me an output of the flash directory. You can see here, this is the iOS I'm using. VOS, TAC, Advent, Enterprise, K9, whatever that says. And that's going to be the file I want to transfer, okay? So we need to look at the actual directory of our flash to see how we want to back up our iOS, because we need the actual file name. And then down here, what we're doing is we're going to copy our iOS, a file on our system, to the TFTP server. So here is the steps. Step 1, from our device here, we're going to transfer to the server, the TFTP server. That's step 2. So what we're going to say from privilege mode is copy a file from our system. So from our directory flash, we're going to copy this file here, which is our iOS, and we're going to send it via TFTP to this destination IP address, which is ding, 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 our TFTP server. And then we have to specify what directory we want to place it in on the TFTP server. So on your TFTP server application or GUI, you have to set the directory that file is going to be transferred into, and it has to match. So on this server, on your GUI, you have to put that you want any TFTP transfers coming into the TFTP-root folder. And you have to specify that in this command as well. We're going to hit enter, and again, it's going to, you can see here, ask us again, what is the address of the remote host? Put in that IP address. That's asking of the TFTP server. And then it says, what is the destination file name? So this is asking for the file name. We're just going to give it a name, right? We can put any name we want here, but in iOS, you have to be specific, okay? And sometimes you got to put that .bin at the end. Just depends. And even G for my viral images, you don't have to. And that's it. So you may be asking, well, what if I want to upgrade from a TFTP server to my iOS? Well, in that case, all you do is flip these two commands. If you want to transfer something from TFTP server to your iOS, you go back into your iOS device router and you're going to type in copy TFTP and then flash. You're going to hit enter, and then it's going to ask you again for the remote host IP address, your TFTP server, and then it's going to ask for the source file name. And depending how you set your TFTP server up, you're either going to have to put in the full path of the directory, or if you already set the TFTP server up to pull from one folder, you're just going to put the file name you need. So ios.bin. And then it's going to ask you for the destination file name. And now you're going to name it whatever you want onto your flash. But again, for iOS, you just keep the same name. And that's TFTP. And in our lab, we're going to do this. It's going to be real simple. All right. So for FTP, it's going to be the same process, but a little bit more. So globally, you have the option to set up a global FTP username and password. Because remember, FTP, you need authentication to be able to connect to an FTP server. Authentication is just username and password. So you can set up a global one that can be used automatically with these commands here. And remember, this username and password is going to be the username and password of the user on the FTP server, not anything related to your Cisco device. This is going to be a user that has privileged access to the FTP that's going to allow you to do transfers. So like if you have an FTP server running on like your Windows machine, depending how you set your FTP server up, you can either create usernames in the FTP application, or you're going to use your system computer or your system's username and password. So it just depends, but you can set that global option here. Another thing you can do is when you actually come down here and do the command, just like TFTP. So here we want to pull from an FTP server. We're going to do copy, flash, and then what we do here is we type in FTP, and then this is going to be the username, the password, the IP address of that FTP server, and then either the full path to the directory or just the direct folder, because maybe your FTP servers already have a virtual path. So again, here's the command. So copy flash your iOS name to this FTP server. Here's its authentication. Here's the IP address, and then the directory path where we want to place our iOS. And then again, if we want to pull from the FTP server, it's just flip these two. And that's it. And if you set up the global, FTP username and password, you don't need this beginning command, but it really just depends on you, what you feel more comfortable with. If I know I'm going to this FTP server, I know the username and password, I just do this anyways, just to be on the safe side. But you don't have to. All right. So that's going to be it for going over how we verify really on TFTP and FTP, guys, is just, did it transfer? And your CLI will let you know if it didn't. They'll give you error messages. So, all right. So I want to thank everyone for viewing, and then stay tuned when we go over our labs. So our first lab is going to be a quick TFTP lab. Then our next lab will be FTP, and it's going to be a good time. Another simple lab, kind of like syslog, just one device, transfer an iOS, and that's going to be it. So I want to thank you guys for viewing, and stay tuned.